Hi children, welcome back to current electricity. So in the last class we have seen the combination of resistors, like if we put two resistors in series, two resistors in parallel, and different problems based on those kind of circuits. So we discussed series parallel combinations in the last class. So today we will be going a little bit advanced. I mean, we cannot simply just by looking at the circuit we may not be able to detect directly like it is parallel combination or series combination like that. So there we will have to apply potential method. I mean, wherever potential is same, that should be considered as same node. Okay, just like this. Suppose if this is a battery, we connect a conductor. So this conductor has, this is nothing but a resistance. Okay, this is a resistance. Now suppose if I write here 10 volt. When I write here 10 volt, this means 10 volt potential difference is there. 10 volt potential difference. When we say 10 volt, it is nothing but 10 volt potential difference. So either I can have plus 10 here and 0 volt here. Potential between this terminal, potential difference between this terminal and this terminal is nothing but 10 volt. That's it. This could be 0, this could be 10. Or otherwise this could be minus 5 and this could be 5 volt. Okay, or otherwise this could be 0 volt and this could be minus 10 volt. Whatever it may be, the real meaning is this battery is able to supply this much potential difference across the circuit. So what happens is, if we consider this as 10 volt, so this is the possibilities, just these are the possibilities I was telling. So but just why to confuse like this? So when we take 10 volt potential difference, the easiest way for us is to consider this as 0 volt and this as 10 volt. So we won't take this, but this is also correct. Okay, now understood? Those who want, note it down. So when I say 10 volt, for our convenience, just we are considering this terminal as 10 volt and this consider as 0 volt. So all of you know what resistor will do. Resistor will eat voltage, correct or what? Suppose if we connect two resistances like this, if this is 10 volt, if this is 5 ohm, definitely here it is going to be 5 volt, because IE is equal to 10 by 10 ohm series combination. This is going to be 1 ampere. So when 1 ampere flows through this here V is equal to I into R, 1 ampere into 5 ohm, we will be getting 5 volt here, 5 volt here. So this 10 volt is eaten by these two resistors. Okay, so pause the screen and whatever you require, note it then and okay, every instant whatever I say, just note it down. Okay, so 10 volt, 0 volt. Now here we don't have any resistance here, no resistance till this, no one to eat this voltage difference or voltage. So here this is also 10 volt, this is also 10 volt, this is also 10 volt, here also 10 volt. Here this is 0 volt, 0 volt, 0 volt, here 0 volt. So this 10 volt will be eaten by this resistor. Clear or what? Okay, understand this. So 10 volt, 10 volt, 10 volt, 10 volt. So wherever resistance is not connected, that potential will be continued where? Till we get a resistance. Okay, please understand this. This concept will help us to do some problems. So we will see problems right away. Find the equivalent resistance between A and B. So this is the circuit. This is B. This is A. Okay, connect like this. This is R. This is R. Connected. So what is the equivalent resistance between A and B? Okay. Now how to solve these kind of problems? So here when we see, we cannot see a series combination or parallel combination directly. We are not able to recognize any series combination or parallel combination directly. So what we should do? See, this is terminal A. This is terminal A. So here this terminal A is here. No resistance in between. This node has what voltage? How much voltage this A has, same voltage this has. So this is also A, this is also A, this is also A. So likewise I can say this is nothing but node A. Same way this is B, here B, here also B. I can say this is also B, B I can say this is nothing but B. Clear or what? Now what we do? Now mark node A, first resistance between A and B. This is also B. First one is done, R. Now this is B, this is A. Second resistance between A and B, this is R. Okay, this is also done. Terminal A, terminal B. Third resistance 1, 2, this is 3. So third resistance also between A and B. So n resistances connected in parallel, equal number of n resistances connected in parallel will give effective resistance like R equivalent is nothing but R by n. So this is 3. So this answer is nothing but R by 3. This is the answer. Note down. If you want, we can consider this voltage as 0 V and this voltage as 0 volt V volt. So likewise, if we want, we can consider like that, but this is easy considering these nodes. So when you connect something like this, B A, if we want, we can assume that this is connected to a battery, and we can, this is V volt means this is V, this is 0 volt, something like that. We can take an imaginary battery setup and think, so that it will be easy to understand. Actually, simply a resistance alone cannot stand with voltage. Definitely there will be battery, but when we get the question, they need not show that battery voltage or something like that. Okay, another question. this is A, sorry, this is A, this is B. Find equivalent resistance between AB. Equivalent resistance between AB. All these are R. R, 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 R. What does this mean? This means that these wires are not touching here. Pause the screen, try to solve yourself. So here is, this is actually what? A battery must be connected, then only we can consider the nodes and all. Okay, right. So here this terminal is A, nothing is connected, no resistances are here, so this can be considered as A. Now this is B, consider this as B. Clear or what? Now we will redraw this circuit. Now A and B, so let's take the first one. Okay, R, R. Now this is also, this is B, this is A. Second one, let's take this as second one. Okay, R, R. So this is also between A and B, this is also between A and B. What about this? This is also between A and B. Okay, so third one is done. Third one is done. This is also between A and B, this is fourth one. So let's draw the fourth one. R, R. So this is A, this is B. Clear? Understood or what? So this is R, this is also R. So two resistances in series, same kind of resistances in parallel. So this is nothing but R equivalent is equal to R by N. Same formula we will apply here. 2R is coming in this in a single branch. Divide by how many branches? 4. Cancel, cancel. This is going to be R by 2. R by 2. So in the options it is going to be given, it will be given like R by 4, 3R by 4, 2R, something like that. R by 2 will be also will be there in the option. We will have to answer that. Note it down. Another question. Okay, so what is the equivalent resistance? RAB. Okay, this question is there in H.C. Verma. I have told you, mentioned about the book H.C. Verma. So this question is there in H.C. Verma. Okay, what is the equivalent resistance between the terminal A and B? Pause the screen, try for yourself. Okay, see, so this is a terminal A. So here we can see another node, this is another node. I name this as X. I am going to name this as X. So if I consider A, node A, from node A, at resistance is going to X, okay, this is R. Now this is also B, no resistance in between. B, this terminal is B, this terminal is B, this terminal is also B. So from X, from node X, A, this is A, resistance R, X, X. Now from X to B, 3 resistances are going. So if I take this as B, if I consider this as B, see, first one from X to B, second one from X to B, so I take this X to B, third one from X to B, we can connect like this, R, R, R. So what is R in series with the R resistance, 3 resistances in parallel, same value resistances in parallel, R plus R by 3. So this is going to be, 3 will come here, 4R by 3. So this is the resistance of this circuit. Another circuit. So this is A, this is B. What is the equivalent resistance between A and B? Options are there. Option A 2R, option B R, option C R by 2, and option D 4R. Okay. So all the resistances are R. The central node is nothing but A, and the other node is B. Now, how to solve this circuit? Pause the screen, try yourself. Now this is one node A, this is another node B. Now if we notice between this node no resistances in between. So if I mark this as X, then I can mark this also as X. Clear or what? Okay. So apart from A and B, there was only one node. So between these two nodes, no resistances, we can consider this as single node. Just like if we connect a battery here, not like this, sorry, battery here, just like this. If we can connect like this, current will start moving. So if we take like that, the voltage at this node and this node will be same. Now we need not draw like that and waste our time. Simply we can consider this as same nodes if no resistances are connected between two nodes. So X and X can be considered as same. Okay. So now we will draw. So this is A. From A, we will take X itself. Okay, from A, one is going to X, another is also going to X. So one resistance okay, R, it is going to, this node is X. Okay, this node is X. Okay, so number 1 is done, number 2 is done. Now between A and B, one resistance is going, and between X and B also another resistance is going. So this is X. If we consider here another node B, here this R is done. So between X and B, this is also done. So between X and B, another resistance is also there. So what we will do, another resistance we will connect here. So between X and B, this is also done. Between A and B, now another resistance. Did you understand how I redrew this figure? Okay, just simply I marked a node here. Since there is no resistance, I marked the same node here. Then I consider node A like this. Then I directly drew 1, then 2. These two resistances to the same node. So this will be parallel. Then between B and X, again this one is also there, this one is also there. So I draw parallel like this. Now between A and B, another resistance is there that I drew like this. Now if I do like this, I will have a better clarity. With this figure, I won't be able to find the equivalent resistance. So each resistances we will calculate. Now this is R and R are parallel. So its equivalent is R by 2. Its equivalent is R by 2. R by 2 and R by 2 are in series. So this will become R by 2 plus R by 2. This is going to be R, this entire circuit. So that is in parallel with another R. Correct? This is A, this is B. So equivalent resistance is going to be R by 2. R and R are parallel. So I get answer C. Clear or what? Pause the screen if you feel confused. Let's see the video once again, just for this circuit, and make it clear. Another question. What is the equivalent resistance between A and B? Question is same, circuits are different. Okay. Pause the screen, solve this. Okay. Now what, again same thing. Now here, this is node A. If we proceed like this, no resistance in between, I can mark here node A. So whatever voltage I get here, same voltage will be available here. Same way here, no resistance, so I can mark here A. This is B. So if we proceed like this, this is going to be B. Same way here, this is also B. So between A and B, this is one resistance. Between A and B, this is second one. Between A and B, this is third one. Between A and B, this is fourth one, and this is fifth one. So 5 resistances are there. Now if you are fast enough, you need not redraw this circuit into parallel circuit and then trying to solve this. No need to waste time like that. If all these are parallel, all these resistances are parallel, directly you can put the equation and you can solve it. So no need to waste time, but I am drawing the circuit. If someone do not understand, just for clarity I am drawing the circuit. Okay, so this is A, this is B, so this is like resistance. So 1 6 ohm, 2 is 2 ohm, here this is 12 ohm, third one, fourth one 1 ohm, then fifth one 4 ohm, 4 ohm. Okay, resistance between A and B. So 1 by R equivalent is nothing but 1 by 1 plus 1 by 2 plus 1 by 4 plus 1 by 6 plus 1 by 12. Why I took like this? Because these are all not divisible each other. They are not multiples. They are not multiples. So we cannot solve 2 and 2 then proceeding with the third one, fourth one. That is not possible. So this is the best thing for solving this circuit. We will take 12 as LCM. Now here 12 will come, here 6 will come, here 3 will come, here 2 will come, here 1 will come, all divided by 12. So 18, 20, 24. 24 by 2, this is going to be 12 ohm. Pause the screen and see the solution. We will see the next question. So this one, okay, so this terminal is A, this is B. We need to find what is the equivalent resistance between the terminal A and B. Okay, so this is B, 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 and this is also B, B, this is also B. If we take like that, all these are B. So between A and B 2R, between A and B again 2R, between A and B R, between A and B R. So we can redraw this A two R, no, R, then this is 2R, and this is also, this is R and R, and this is B. So 2R parallel, we will be getting R. R and R parallel, we will be getting R by 2. So R and R by 2 in parallel. So R into R by 2 divided by R plus R by 2. So what we will be getting? R square by 2 divided by, this 2 will come here, we will be getting 3R by 2. 2 will be cancelled off, this R and square will be cancelled off, this is going to be R by 3 ohm, R by 3 resistance. Clear or what? So just wherever resistance is there in between, just mark, extend that node to the other node, other terminal. Then find which all resistance are common between nodes, between different nodes. Then just you will be getting some combination of series or parallel, then you can apply like this. So these many questions are enough for understanding this concept. Now we will see infinite network. Now we will see infinite network. Previous problems were potential method, where wherever potentials are same, so those we will consider as nodes and we solve the problem. Now this is infinite network. These kind of networks are we can get these kind of networks also. By taking one example, we will see. This goes up to infinity. Okay, terminal A, then terminal B, okay. So this kind of network, terminal A, terminal B, some ladder kind of resistances will be given and that will be going to infinity. So how to solve these kind of problems? Okay, so how to do is, first we need to assume that the resistance of this infinite network be something like X or something. Then we need to find the repeating units of this circuit. So for example, R and R repeating everywhere, R and R combination you will be able to see. So that also we need to find. Then we need to solve this. I'll show you how to solve this. Take this circuit. So step 1 is, let X be the resistance between terminal A and B. This is point number 1. Another is, find the repeating unit. Find the repeating unit. So here the repeating unit is this. So here if we make mistake in finding the repeating unit, then entire problem will go wrong. So we need to be careful about this. Okay, third step is, leave one repeating unit and find the equivalent resistance of remaining. Third step is, leave one repeating unit. Leave one repeating unit and find the equivalent resistance of the remaining. Okay, leave one repeating unit and find the equivalent resistance of the remaining. So here, this is the repeating unit. So it goes like this. Okay, this is terminal A, terminal B. Now leave this part. Find the resistance of that part. Find the resistance of remaining. Okay. Now this is R, 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 R. First step was, consider the resistance of the whole network, infinite network, as X. Then find the repeating unit. Third step is, leave a repeating unit, then find the resistance of the remaining. Now if resistance of the infinite network is X, suppose even if we leave one repeating unit, then also the resistance of the remaining part is going to be X. Correct or what? Because infinite ladder or infinite resistance infinite resistances are connected, its equivalent resistance is given as X. So even if we drop one repeating unit, what difference it is going to make to that X? We are leaving only one. We have already assumed that the full is X. So we just leave one. What will be the resistance of remaining? That also will be X. So that X we will have to connect here. Did you understand what I am telling? So the resistance of this unit, entire remaining these things are going to be what? X itself, because the total resistance of this infinite network is X only. This is our assumption we have taken. Now we left one repeating unit and we are finding the resistance of remaining, that is nothing but X. So this is going to be X itself. This is going to be X itself. Note down. Okay, why? Because infinity plus or minus something is going to be infinity itself. So with X, whatever we add, whatever we delete, this is going to be X itself. Now what is the equivalent resistance now? Now 1 by R equivalent is equal to, between this and this, 1 by R plus 1 by X. Correct or what? 1 by R equivalent is equal to 1 by R plus 1 by X. So I can write here R equivalent, okay, of this is nothing but Rx plus, R into X divided by R plus X, about this part. Now if we consider this also, R equivalent total is nothing but, this is series with this network. So R plus R into X by R plus X. Clear or what? Now what was the initial resistance? Initially what we considered as the resistance of the whole network? X only, right? X is what we assumed the resistance of total network. So the entire network also we can take as X, and this full also we can take as X. So I am replacing this thing with the X again. X is equal to R into R plus X plus Rx divided by R plus X. Now we will simplify this to find the answer. Note down. So X into R plus X is equal to R into R plus X plus Rx. Simplify this. Okay. So Rx plus X square is equal to R square plus Rx plus Rx. So X square, if one Rx will be cancelled off, this can brought to this side. Rx minus R square is equal to 0. Now this is a quadratic equation. So X is equal to minus B plus or minus root of B square minus 4AC divided by 2A. Okay, so X is equal to minus B is what here? Minus B is R. So minus of minus B. So we get R. Plus or minus root of, what is B here? Minus R whole square. So R square minus 4 into, coefficient of X is nothing but 1. C is nothing but R square into minus R square 4AC divided by 2. Okay. So X is equal to R plus or minus root of R square minus, so this will become plus, minus minus, 5r square, I'm sorry, 4r square divided by 2. So x is equal to r plus or minus, this will become 5r square divided by 2. So x is equal to r plus or minus root 5r. R from root, if we take r square outside, this will become r divided by 2. So x can be r plus root 5r divided by 2, or x can be r minus root 5r divided by 2. Root 5r is greater than r. So if we take this one, resistance value will go negative. This cannot be possible. Root 5r is greater than r. So we can take, this is the correct solution. If we take r outside, we will be getting root 5 plus 1 divided by 2. So this is the value of resistance of this infinite network. So I will summarize the concept. We will do one more problem. Infinite network. Consider the resistance of whole network as x or y or whatever it may be. Okay. Second step, find the repeating unit. Okay. Third step, keep one repeating unit as such. Okay. And find the resistance of remaining and attach to it. So there we will be taking as the entire thing, the resistance of entire thing is taken as x. So even if we leave one repeating unit also, the resistance of remaining will be x itself. So connect that x there. Find the equivalent resistance. We will be getting quadratic equation. Solve it, we will be getting the answer of resistance. So this is the method. Note it down. Another problem of same type. Okay, infinite resistance type. So R, A, B, okay, resistance R, this is resistance R, R, R. So this can be extended like this. So what is the equivalent resistance? R, A, B. Okay, so first step, pause the screen, try to solve for yourself. If you solve yourself, then only your skills will improve. If you keep copying the solutions from the board, your skills will not be improved. So pause the screen and compulsorily you should try for yourself, then verify the answer here. Pause the screen, do it. So let the equivalent resistance between A and B X. Okay, first step. Second step, find the repeating unit. Repeating unit is nothing but this is the repeating unit here. So one resistance like this, another resistance like this. This is the repeating unit here. Correct. Now consider this other part resistance and attach to it. So third step is that. So what will be the resistance of that remaining part if we leave one repeating unit? Same, X itself. Okay. So this is X, this is R, this is R, A, B. Now find the resistance of this circuit. Now what about this resistance and this resistance are in series or parallel? Now they are in series. Okay, so R AB is nothing but this resistance is in parallel with this series resistance. So R into R plus X divided by R plus X. Okay, this one parallel with this series. R plus X is series. So R into this resistance plus by R plus this resistance. Clear or what? So equivalent, this one I will write the equivalent resistance of this part. Equivalent resistance of this part is nothing but R plus X. So that is in parallel with this. This and this are parallel here. Okay. Okay. Now what we can take for this X left hand side, LHS can be considered as total resistance X, which we have already assumed. So X is equal to R into R plus X. R into R plus X divided by R plus X. Clear or what? So we will solve this, we will get the answer. Note it down. We will solve this. This will become a quadratic equation, and by solving that quadratic equation we will be getting the answer. Okay, so we'll bring to this side. X into this is 2R plus X. This is equal to R square plus Rx. So 2Rx plus X square is equal to R square plus Rx. So this 2 and this Rx will be cancelled off. X square minus R square, sorry, this will take X square plus Rx minus R square is equal to 0. Now we will find X is equal to minus B plus or minus root of B square minus 4AC divided by 2A. So here B is nothing but R, A is nothing but A is 1, coefficient of X square. B is nothing but coefficient of XR. C is nothing but coefficient of R square, which is nothing but minus 1. Okay, so minus B minus R, X is equal to minus R plus or minus root of B square is nothing but R square. B square minus 4 into AC 1 into minus 1 by 2 into A. So this is how. So X is equal to minus R plus or minus root of, here one term is missing, B square minus 4 into A into C is nothing but C is here. C is actually R square. C is R square. So here minus R square will come. Minus R square. Okay. So R square plus 4R square divided by 2. Okay. Clear? So X is equal to minus R plus or minus root 5R square divided by 2. So x is equal to minus r plus root 5r square. So we will simplify. X is equal to minus r plus or minus root 5r divided by 2, or minus r minus root 5r divided by 2. So in this, which one we can take? So here plus this root 5r is greater than minus r. Here if we consider this, here the answer will be negative, we cannot take for resistance. So this one we can consider. R if we take outside, root 5 minus 1 divided by 2. So this is the equivalent resistance between A and B if we solve this circuit. Okay, so potential method, what you need to do, whatever a node voltage we have got, any node might have marked like A, B, X or something. So wherever resistance is not connected, that node voltage will be same to the other node. So extend that node name to the other node to find the series and parallel. For infinite resistances, okay, first we should consider the equivalent resistance as X or something. Then find the repeating unit. Leave one repeating unit, put the resistance value X attached to this repeating unit. Then find the equivalent resistance. Equivalent resistance already we have assumed as X. So put in the left hand side X. Then when you proceed, we will be getting a quadratic equation. Solve the quadratic equation, we will be getting the answer. So dear students, these are one varieties of equivalent resistance to find equivalent resistance, one kind of questions. In the next session also we will be proceeding with the equivalent resistance only. Just by doing that, we will be very handy with the circuits. Then only we will be able to handle the real circuit problems well. Okay, this is easy, but apply the skills, electricity related concepts and skills on the circuit, and practice, we will become very fluent in dealing the circuits. Okay students, hope you enjoyed the class, you understood. Okay, thank you, goodbye, good luck.